Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique solid is the one which happens to be inclined to both the reference planes, that is horizontal plane and the vertical plane. So let us evaluate the orientation of the given regular pentagonal pyramid with respect to the two reference planes. So here we have with us a right regular pentagonal pyramid of base h 30 millimeter, axis height 75 millimeter. It is resting on one of its base corners on the horizontal plane such that the axis is inclined at an angle of 45 degree to HP, and the side of the base opposite to the corner which is lying on the horizontal plane is inclined at an angle of 30 degree to the vertical plane. So we are required to draw the projections, that is front view and the top view projections of this oblique solid. So to begin with, we have understood after going through the statement that this particular regular pentagonal pyramid is resting on one of its base corners on HP. That is, it is resting initially on the horizontal plane with its pentagonal base resting onto the horizontal plane. And in the first orientation, this axis of this pyramid is inclined at an angle of 40 degree to the horizontal plane. So first of all, we are going to draw the true shape of the base of this pentagonal pyramid onto the horizontal plane in the top view. So since this is resting onto the horizontal plane and the axis is in the upright position, that is the axis of this pyramid is at an angle of 90 degree to the base. So first of all, having worked out that we are going to observe this pentagonal true shape onto the horizontal plane, so this will be drawn below the XY line. First thing, it is very much clear. Then we need to understand that whether it is this orientation or it is some other orientation that we need to work out regarding the construction of this true shape below the XY line. So there can be two orientations in which we could have drawn this pentagonal lamina over there. Basically the base becomes a lamina, right? So the shape of the base is nothing but it is a plane surface. So this pentagon that we have to draw below the XY line, we can draw into these two orientations. So let us work out which orientation satisfies the conditions which are provided to us in this statement. So let us pick up this case first. So if we are going to orient our pentagonal pentagonal pyramid in this orientation, what is going to happen? The axis of this pentagonal pyramid is inclined at an angle of 45 degree to HP. So I can rotate this either in this orientation or I can rotate this in this orientation. So the axis can be inclined either over here or in this orientation. So in either of the two orientations, one condition is satisfied, that this pentagonal pyramid will be resting onto the horizontal plane on its corner of the base. Just see, if I either incline it this way, it will be resting on this corner of the base. If I incline this pyramid in this way, then it will be resting on the horizontal plane into this corner over there. But what will happen if I tilt this particular pentagonal pyramid either this way or this way? It will be resting on the ground on one of its corners of the base. That is satisfied. But the second condition, the side of the base opposite to the corner is inclined at an angle of 30 degree to the VP. So corresponding to this, the opposite side is this one. Similarly, corresponding to this corner, the opposite side is this one. But the moment we incline this, the side opposite to this corner or the side opposite to this corner, that is, it would be either this side or it would be this side, it would have been made apparent length into the plan view which we are going to obtain over there. That is, this opposite end, either this way or this way, it is no longer the true length, which has to be inclined at an angle of 30 degree to the vertical plane. So this situation is not satisfied. Thereby we can see that if we are going to have our pentagon drawn below the XY reference line in this orientation or in this orientation, then I am going to tilt this pentagonal pyramid in this way. That is, the axis will be rotated like this, and the moment I rotate the axis like this, it will be, you can check, resting on the horizontal plane on one of its corners of its base. So that is fulfilled. This condition was even satisfied in this case. But when I rotate this particular apex or the vertex like this, in this way, so that the corner will be resting onto the ground, and the opposite side, just see, this is the opposite side which is opposite to the corner which is resting onto the ground, this side. So this side is still parallel to the horizontal plane now, and since this side is still parallel to the horizontal plane, its projection on the horizontal plane will be available with me as a true length. And now this true length I have been provided with the data that the edge of the base which is opposite to this corner, that is this one or this one, this is inclined at an angle of 30 degree to the VP. So this way, this is the correct situation, and this situation does not fulfill the requirements which are required by this statement. So let us start drawing the projections. So step number 1, you draw the XY line. Now we are going to draw the pentagon base over there because we are looking from the top. So the projections of the pentagon, that is true shape, will be obtained onto the horizontal plane because the pentagon is resting onto the horizontal plane with its base over there, onto its base. So once you draw this pentagon, I know the edge, that is 30 millimeter. So I'll do the marking of 30 millimeter. Let us label all these points. A, just check it out, A, B, C, D and E. These are the 5 points of the base of the pentagonal pyramid. Then next I need to work out the center of the axis, because the front view I can draw once I know the axis point, and second I am provided with the height of the axis over there. So in order to work out the axis, I need to draw perpendiculars from all the 5 corners onto the bisectors of the opposite edges over there. So from D I will be drawing perpendicular bisector on AB. From E I will be drawing perpendicular bisector on BC. From B I will be drawing perpendicular bisector onto ED. From A I will be drawing perpendicular bisector onto CD. This way, from E I will be drawing perpendicular bisector onto BC. So this way 5 perpendicular bisectors from the 5 corners of the base I have drawn onto the opposite edges of the lamina over here. Now you see, having obtained this center point, I have been able to obtain this center point, and one thing I need to obtain, remember over here, that this axis center point will be lying below this line, straight line, which will be joining these two ends E and C. Because this thing, why I am telling you, because many students, what they'll be doing, they'll be just projecting this C and E and they will treat it to be an axis line. No, this is not the axis line. Axis line will lie slightly below this imaginary horizontal line which will be joining the corner C with E. So here we have located the axis point. The moment we locate the axis point, we can mark these 2 points O and O1 over here. O point will correspond to the vertex or apex, and O1 point will be corresponding to the bottom point which will be lying onto the base of this particular pentagonal pyramid. So having located this O and O1, now we need to join all the slant edges. You can see, if you are going to look at this particular pentagonal pyramid, all the 5 slant edges, they will be visible to you as you are looking at this pentagonal pyramid from the top. So the base is the pentagon which is visible. All the slant edges, they are also visible. So we have darkened them using the object lines or the HB pencil. Now having drawn this top view, now I have just removed the construction lines through which I had worked out the axis, just to make my view clearer over there. Now I am going to draw the axis line. I know the axis height. How much is this? 75 millimeter. So now you see I am going to draw the projectors through B and A. Similarly, draw projectors through C and E and draw projector through D. So wherever they intersect the vertical plane, my front view points of the base, they will be evaluated, they will be located. So B dash and A dash, they have been located here. C dash and E dash, they have been located here. And point D dash has been located here. And please see, C dash and E dash, they are different. Axis point is below this particular, it is behind this particular projection of C dash and E dash. So this is the O1 dash point, which is the point which is available at this bottom of the base over here. Now we are going to measure this 75 millimeter axis height. So once we measure this 75 millimeter axis height, point O dash will be located here. And having located this point O dash, now all the slant edges we are going to join. O dash with B dash A dash, O dash with C dash E dash, and O dash with E dash. And here you need to remember one thing. Projection of OA in the front view is the hidden line. Just see, it is not visible to the observer directly. OA, that is O dash A dash, is hidden, that is it should be dotted, but this is being overlapped by the projections of O dash B dash, that is O dash B dash, because these two lines, they are in same line, same projection line over here. So O dash A dash, so though it is hidden, that is dotted, so it will be overlapped by O dash B dash. So that is why we don't show the hidden line over here. So O dash B dash and O dash A dash, they are represented by this single line. So even though O dash A dash is hidden, that is dotted. Similarly, O dash C dash, O dash E dash is also dotted. Just see, it is available behind this particular surface. So this is hidden, so this should be dotted, but this is overlapped by O dash C dash. So O dash C dash, it is going to cover the projections of O dash E dash. So again there is a solid line. Then OD, it is clearly visible, so you will be getting a dark line over here. So this way the front view has also been completed over here. Now you see, since front view and the top views have been completed, now we are going to the first iteration, that is the pentagonal pyramid is resting on one of its base corners on the horizontal plane such that the axis is inclined at an angle of 45 degree to HP. Now you see, this is my axis O dash O1 dash. This is the axis which needs to be made inclined with respect to HP at an angle of 45 degree. Now I can rotate it this way, I can rotate it this way. If I rotate it this way, what will happen? My pentagonal pyramid will be resting on edge of the base, not on the corner of the base. So this rotation is discarded. Similarly, you can check over here. This is my pentagonal pyramid. If I rotate it like this, it will be resting on the edge, not on the corner. But I have been provided with the fact that it is resting on one of the base corners. So it must rest over here onto corner D. So I have to rotate it this way. So this rotation has to be like this. So now let us see how this will be rotated. So this complete picture, you can see, this complete front view projection has to be drawn at an angle of 45. So as we have already discussed, the angle of inclination of the axis is 45. So we are going to use 90 degree minus 45 degree is equal to 45 degree. So we are going to rotate this entire triangular figure over there with respect to base, because we want to make sure that this pentagonal pyramid should be resting right onto the horizontal plane at point D dash. So the base will be transferred at an angle of 45 degree. So we are going to transfer this figure at an angle of 45 with respect to the base, and then it will be easier to transform this figure over here, because in this case it is very easy to point D1 dash over here. Otherwise, if we start with axis 45, then we have to manage that this triangle should be moved up or down, so that this point D1 dash should be lying on the XY line. Because many a times it happens, if we have this line slightly lower or slightly higher, then either this D1 dash will be lying above the horizontal plane or it will be lying below the horizontal plane, which is unwarranted. So what we are going to do, axis angle, it is subtracted from 90 degree, and this will give you the angle of the base. So the angle of the base becomes 45 degree, because the axis angle is 45 degree over here. Now let us see how do we transfer this figure over here. So once again, rectilinear distances will be used. I am going to mark 4 points over here. Point number 1, D dash. Point number 2, C dash, E dash. Point number 3, C dash. And point number 4 is A dash, B dash. So this length will be divided into 4 points. Point 1, 2, 3 and 4. So I am going to mark this length over here and mark point 1, point 2, point 3 and point 4. So corresponding to point 1, point 2 and point 4, the vertical distances are 0. So straight away the moment I mark points 1, 2 and 4, so points D1 dash, C1 dash, E1 dash and point B1 dash, A1 dash, they are automatically located. Then from point 3, which is at a distance of this much from D1 dash over here, I am going to draw the vertical perpendicular line having axis length is equal to 75 mm. So this length is already given to me 75. So from here I draw a perpendicular axis line 75 mm long. So once I draw this and mark this point, so O1 dash will be located. The moment O1 dash is located, I can join O1 dash with B1 dash, A1 dash. I can join O1 dash with C1 dash, E1 dash, and I can join O1 dash with D1 dash. And then axis is this one. I will be extending this axis, and now I can mark this angle equal to 45 degree. So once I mark this angle 45, just see, and the moment I do this marking, I am going to rub this off. So this 45 degree will be rubbed off. Reason? Because in the statement angle was not provided to me with respect to base. Angle was provided to me with respect to the axis over there. So since by measuring angle with respect to base, transferring this picture over here becomes easier, because you don't have to worry about locating point D1 dash onto the XY line. So now I am going to do away with this 45 degree. Now having drawn the front view, now the next step is to draw the fourth view. So the first view was the true shape of the base, second view was the front view, third view is rotation or translation of the previous elevation view, fourth view is the corresponding view. So in the corresponding view, you see how many points we do have over here. 5 points for the base, 2 points for the axis, 7 points we do have. So we have, from all these 7 points, we are going to bring down vertical projectors, and from all the 7 points of the previous view of the plan, we are going to draw the horizontal projectors over there. And let us try to work out the corresponding points. So point number 1, you can see this is point C1. So the vertical projector from C1 dash, wherever it intersects with the horizontal projector from the plan projection C, we get point C1. Similarly, O1 dash, you draw the vertical projector. Since this is the axis line, just see marking of axis has been done. And draw the horizontal projector from O. So wherever these two intersect, you get point O1. Similarly, this is the vertical projector from D1 dash, and wherever it intersects with the horizontal projector from the previous plan projection D, you get the point D1 over here. Similarly, O11 dash, so you bring the vertical projector from O1, you draw the horizontal projector. Wherever these two intersect, you get second axis point O11. Similarly, you have E1 dash vertical projector and horizontal projector through E giving you point E1. And next you have point A1. Just see, vertical projector through A1 dash and horizontal projector through A gives you A1. And similarly, vertical projector through B1 dash and the horizontal projector through B gives you B1. So just see, all the 7 points have been located. So we know very well A, A1, B1, C1, D1, E1, A1, they have to be joined. Then A1, O1 has to be joined, A1, B1 has to be joined, A1, C1, A1, D1, and similarly A1, E1 has to be joined. So this thing we remember, but only thing we need to work out right now is which lines you have to draw dark, which lines you have to draw hidden, that is dotted one. So since you see, observer is looking at this particular pyramid from the top, so we need to evaluate those points which are farthest away from the observer and closest to this XY reference line. So as the observer is looking from the top, this is the point, check it out, D1. You see, if I tilt it this way, so this point D1 will be at the bottommost position. So this will not be visible. So if this point is not visible, so CD will be dotted, DE will be dotted, and DO will be dotted. These are 3 lines which will be dotted. Why? I am tilting it this way. The moment I tilt it this way, this portion of the pyramid is going to cover this portion which is starting from point D. So DC, DE and DO. So here we have the model which we can use appropriately to work out which things they are visible and which things they are not visible. But over here it's very simple. You are looking from the top, work out the point which is farthest away from the observer. It is point D. So I automatically make out one thing, anything which is going to join with D1, this will be dotted. That's as simple as it can be. So let us start joining the points. Just see, I am joining all these points as I told you that we are going to join A1, B1, C1, D1, E1, A1. And we are also going to join O1, A1, O1, B1, O1, C1, O1, D1 and O1, E1. So I told you that whichever points they are going to join with D1, because D1 dash was the point which was farthest away from the observer and nearest to the plane, that is this XY reference line. Using model, you just see, once you tilt it over here, so this portion will be covering CD as well as DE as well as DO or OD. So just see, these are the 3 lines which we have drawn dotted over here. So having drawn this top view, when this pentagonal pyramid was having its axis inclined at 45 degree with respect to the horizontal plane. Now we want to draw the third case. So the second iteration is, we are provided with the fact that the base opposite to the corner, you see, this is the corner on which it is resting, D1, just see, D, and the base edge opposite to this corner is which one? This one, AB. And you can see in this figure, A1, B1 is still parallel to the horizontal plane. Just see, even if you lift it this way, initially it was resting on the horizontal plane. Even if you move it this way, this AB, it will still be parallel to the horizontal plane. And since this is still parallel to the horizontal plane, so the projection A1, B1 is still true length. So if this projection is true length, that is why we are saying that the base opposite, it means we are talking about true length of the base edge over there. So this is the base edge A1, B1, which is still true length. We are not talking about the plan over there. We are not talking about the apparent length of the base edge opposite the corner. So this is still the base edge which is opposite to this corner and this edge. Now we have to rotate this figure with respect to this edge, making an angle of 30 degree to the VP. So now I will be drawing angle of 30 degree either this way or this way. Just see, I have drawn the angle of 30 degree over here. Now after drawing the angle of 30 degree, I need to again transform or rotate this figure, whatever plan projection has been obtained, in such a way that this edge which is opposite to this corner. So the edge of the base which is opposite to the corner on which it is resting onto the ground. So this edge happens to lie onto this projection line which has been drawn at an angle of 30 degree. So we call this angle as angle phi. So once again, using rectilinear projection method, we are going to transfer all these points over here. So how many points we need to transfer? 7. 5 for the base, 6th for the axis point on the base, and the 7th one will be the apex point. So let us see how we are going to shift all those points. So let me explain. Over here, again I am going to divide this into number of portions. Point number 1, you can see this is my point number 1, this is my point number 2, this is my point number 3, this is my point number 4, and here my point number 5 lies. So point number 1, point number 2, point number 3, point number 4, you extend this line, here you get point number 5. So all these 5 points I have marked. So please check, I am going to mark all these 5 points over here. Point 1, point 2, point 3, point 4, and point 5. So through point 2 and point 4, you see point 2 and point 4, wherever they are marked, vertical distances are 0. So A1 and B1, they are located at points 2nd and 4th. So A2 and B2, they are located at points 2nd and 4th. Now let us check at point 1 and point 5. So this distance of E2 and C2 is equal, which is equal to this distance of E1 from this locus line and this distance of C1 from the locus line. So why we have not drawn this? Because this distance is already equal to this thing we remember. So since we measure this distance, automatically this is equal to this distance, which will be at point number 5. So from point 1, I get the location of E2. From point 5, I get the location of C2. So 4 points they have been located, that is A2 and B2 corresponding to 2nd and 4th points, and for 1st and 5th points I have been able to locate E2 and C2. Next I have got point number 3. From point 3 I will be measuring this distance. This will give me location of O21. So just see, measure this distance, axis point O11. So I will be getting this distance axis point O21. Similarly, onto point 3 locus line, vertically measure this distance, I will be getting the location of D1. Similarly, from this you measure the vertical distance, I'll get D2 over here. And finally, from this point, measure this vertical distance of O1. So I will be getting, from this point, measure this vertical distance, O2 will be located. So all 7 points, they have been transferred. So now you draw all the lines, dotted ones and the dark ones, just in the same way as they were drawn in the view number 4. So in the same way, all these points, they will be joined by dark or the dotted lines as they were done in the previous view. So this plan projection view has been successfully transferred over here. Now, after the successful transformation or rotation of this view, that is the edge opposite to the corner on which it was resting, that has been transformed at an angle of 30 degree angle, which is angle phi. Now we need to draw the front view projections of this oblique lamina. Top view projections, they have been obtained. So in step number 6, once again the corresponding points we are going to work out. So from all these 7 points which are available over here, now we are going to draw vertical projectors. Just see, so please check, these were the markings which were used to transfer the distances rectilinear way. So I have removed them just to make my picture clear. Okay, now I will be drawing the vertical projection lines. Just see, this is O2, vertical projector from O2 and the horizontal projector from O1 dash. I obtain the apex point O2 dash. Next, from point E2, I have drawn the vertical projector. From E1 dash, I have drawn the horizontal projector. Wherever these two intersect, point E2 dash has been located. Similarly, vertical projector from C2 dash and horizontal projector from C1 dash, wherever they intersect, I get C2 dash over here. Similarly, vertical projector through B2 and horizontal projector through B1 dash intersection point gives me B2 dash. And next I obtain horizontal projector through D1 dash and the vertical projector through D2 intersection point as D2. And next one, I need to locate point of A. So vertical projector through A2 and the horizontal projector through A1 dash gives me A2 dash. And finally O21 is also located. And having located all these points, 7 points have been located. Now I need to join again in the same way. A2 dash, B2 dash, C2 dash, D2 dash, E2 dash and A2 dash. This pentagon face will be joined. Similarly O2 dash, A2 dash, O2 dash, B2 dash, O2 dash, C2 dash, O2 dash, D2 dash and O2 dash, E2 dash will be joined. So I know how many points and how many edges I want to obtain. But question is, which one of these edges or the lines will be dark? Which one of these edges will be dotted? Now once again it is very simple. Please check. I am looking from this side. Your observer is standing over here as it is looking at this plan projection view. So as the observer is looking from this side, which is the farthest point from the observer? A2. Please check. A2 is the farthest point from the observer. So since A2 is the farthest point from the observer, any of the lines which are going to join A2 dash, they will be drawn dotted. Rest everything will be drawn with the help of object line or the darker line. So once again I repeat, since the observer is going to look at this particular plan projection view from this side, so this is the farthest point from the observer and A2 is the nearest point with respect to the XY reference line. And corresponding to A2 we have got A2 dash in the front view. So any lines which are going to join with A2 dash, so what are those lines? A2 dash, B2 dash, A2 dash, E2 dash, O2 dash, A2 dash. So these three lines, they will be dotted. Rest all of the lines, they have to be drawn using object lines or the dark line. So you can just see this image. So you will find that these are the three surfaces, surface 1, surface 2, surface 3, which have overshadowed this surface as well as which has overshadowed this surface. So these three surfaces, they have overshadowed this surface as well as this surface. That is why the lines which are joining these surfaces, they have been drawn dotted. So these surfaces or the edges, they are not visible from this side. So that is why O2 dash, A2 dash, A2 dash, B2 dash and A2 dash, E2 dash, they have been drawn dotted, which is very easy so far as visualization is concerned. This surface is visible, draw dark. This surface is visible, draw dark. This surface is visible, draw dark. This surface goes behind this surface. Similarly, this surface, it goes behind these two surfaces. So that is why the surface O2 dash, B2 dash and A2 dash is not visible. Surface O2 dash, A2 dash and E2 dash is also not visible. So that is why these three lines, they have been drawn dotted over here. So this is about the projection. Now let us even join the axis point. O2 dash, axis top has been located. O21 dash, that is axis bottom point, has been located. So now we have joined even the axis over here. This is how the axis point will look in the front view. So with this, we have completed the projections of the right regular pentagonal pyramid, which is having its axis inclined at an angle of 45 degree to the horizontal plane, and the edge which is lying opposite to the corner, which is resting on the horizontal plane, it is inclined at an angle of 30 degree to the vertical plane. We'll be continuing with the further discussion on few more cases on the projections of the oblique solids in the subsequent lectures in this lecture series. So thank you very much. Thanks a lot. Thank you.